All right, let's dive right in. Today, we are taking a deep technical look at Google's Gemini 3.1 Pro. And I want to be super clear about this from the get-go. This is not just some small incremental update. The research we're looking at points to a massive architectural shift. We're talking about a move away from AI as just a chatbot and into a world where it's an autonomous agent that can actually reason, plan, and act on its own.
So let me just start with a question. What if an AI could do this? I'm not talking about just generating a flat image. What if it could truly understand the physics, the math, and the code required to literally engineer a complex animated graphic, an SVG, from nothing more than a simple sentence? Well, this isn't science fiction anymore. It's actually a key benchmark that shows us the kind of new cognitive horsepower we're working with here.
And really, that's the whole point of our deep dive today. We are moving past the idea of simple conversational AI. The new frontier, the thing that matters now, is building what are called autonomous agentic ecosystems. Think about it. Systems of multiple AI agents that can think, plan, and execute really complex, multi-step tasks out in the real world. And it's all powered by the new engine inside Gemini 3.1 Pro. Okay, so let's get into the mechanics of it. To really grasp what makes this new era of agents even possible, we have to start at the foundation. We have to look at the huge changes Google made to the model's core architecture, to how it actually thinks. And it all starts with this one single number: 1,048,576. That is the number of tokens in Gemini 3.1 Pro's context window. And this one spec, believe it or not, changes absolutely everything about how we can build AI applications from now on. So, for years, if you're a developer, you've been stuck with these complex and, let's be real, often pretty unreliable pipelines called Retrieval Augmented Generation, or RAG. You'd have to chop up your documents, embed them in a vector database, and then just hope that you could pull out something close enough to the right answer. Well, that's the old way. The new way is direct ingestion. You can feed an entire code base, years of financial records, or a huge legal file directly into the model's active memory. For a ton of use cases, this completely gets rid of those messy, unreliable RAG steps. The next huge shift is how the model thinks. It's a new system called Dynamic Cognitive Allocation. The easiest way to think about it is like a volume knob, but for reasoning. Instead of us trying to trick the model into thinking harder by adding clever phrases to our prompts, we now have a native API parameter called thinking_level. This means developers, for the first time, have direct control over the model's cognitive depth. And this has a massive implication for developers. All those old habits you learned, they're not just outdated, they're actually counterproductive now. Manually typing things step by step into your prompt literally gets in the way of the model's new internal reasoning engine. So the new protocol is simple. Write a direct, clean prompt and then control the cognitive effort using the API. It's a whole new way of working. Okay, so the architecture is new, the context window is enormous, and the reasoning is dynamic. But how do we prove it's actually better? Well, for that, we have to look at the hard data, at the benchmarks. And this is really the most important question, isn't it? We don't care about memorization. That's an old game. What we want to know is, can a model genuinely reason its way through a tough problem that it has never seen before in its training data? And to test that, you need a very specific and notoriously difficult benchmark. And this is the number that has the entire industry buzzing, 77.1%. So what is this? This is Gemini 3.1 Pro's score on the ARC-AGI 2 benchmark. And the absolutely critical part is that this is a zero-shot result. That means the model solved these incredibly abstract reasoning puzzles cold, with no hints or prior examples. And just look at this chart to see how insane that achievement really is. This isn't a small 10% bump. Gemini 3.1 Pro more than doubled the performance of the model that came right before it. This is, without a doubt, one of the biggest single-generation leaps in reasoning ability we have ever seen in AI. It suggests a fundamental shift from just matching patterns to genuine, flexible problem-solving. So how does all this raw power actually translate into tools that developers can use in the real world? That brings us to what Google is calling the new API primitives. These are the building blocks for creating reliable, production-ready autonomous agents. First up is something that sounds small, but is actually critical for enterprise use: a new specialized API endpoint. Now, this isn't just another URL to call. It's a dedicated routing system, and it's specifically tuned to force the agent to use the custom safe tools you define. It stops the agent from getting lazy and just falling back on potentially risky generic commands. It's all about control and safety. Next up is a feature that will make every developer who's worked with LLMs breathe a huge sigh of relief: enforced structured outputs. You can now give the model a strict JSON schema and it guarantees a 100% valid output every single time. This completely kills the need for all those messy validation loops and retry logic. In fact, some partners are already reporting up to a 6-fold reduction in API calls on their data extraction workflows. This is huge. This is how you start to bridge the gap between unpredictable AI and the deterministic software we need to build. Okay, this next one is a total game changer. For a long time, function calling was just text in, text out. Not anymore. We now have multimodal function responses. So the agent can ask for a tool to be run, like take a screenshot of the screen, and then your code can return the raw image data directly back to the model. The agent can literally see the results of its own actions. This closes the sensory loop and makes true visual automation of graphical interfaces a reality. So we've got a new architecture, we've got a powerful new toolkit for developers. But what can we actually build with all this? Let's take a look at some of the new paradigms that this tech is starting to unlock. Let's go all the way back to that hook from the beginning, that pelican riding a bicycle thing. When researchers ran this benchmark, the model took over 5 minutes, a 323.9-second thinking trace, just planning, calculating, and reasoning before it wrote a single line of code. The final output was this mathematically perfect, animated SVG that correctly handled things like 3D depth and physics. This isn't just spitting out code it's seen before. This is active computational visual engineering. And that engineering ability leads to this new development style people are calling vibe coding. Instead of writing out every single tiny instruction, you can now just describe the intent, the layout, and the aesthetic vibe of an application you want. The model's deep reasoning can then take that high-level description and generate a full functional React dashboard. You can literally go from a conversation to a deployed app in minutes. But it's not just about creative coding. Gemini 3.1 Pro has been specifically optimized for the messy, complex, long-running tasks you find in enterprise finance. The Finch benchmark is all about testing an agent's ability to work across thousands of different spreadsheets and millions of cells. And thanks to that 1 million token context window, the model can now finally tackle these huge financial automation jobs that would have completely broken older models. And finally, let's cover some of the essential protocols, the tricks you really need to know to get the most out of this new model. Because this is a whole new architecture, and it means some of our old developer habits have to be unlearned. All right, the most important point, and I'm going to say it again because it's that crucial, you have to stop overprompting. We have all been trained for years to add phrases like think step by step to our prompts. You have to stop. These are now counterproductive. You need to trust the thinking level API parameter. Simplify your prompts, be direct, and let the model's native reasoning engine do the heavy lifting for you. Now listen up, because this is a critical, non-negotiable update for any developer using the Gemini 3 series. The old advice was always to lower the temperature setting to reduce hallucinations, right? That advice is now dangerous. For these models, the temperature must be set to 1.0. If you change it, you can severely degrade the model's reasoning ability and even cause it to get stuck in infinite loops. This is a big one. And here is a real power user strategy for those long, complex coding sessions. See, even with 1 million tokens, your conversation history can get cluttered with dead ends and old mistakes. We call this context rot. The way to fight it is simple. After you finish a big feature, have the agent write a detailed summary MD file of what it just did. Then, just abandon that chat session, start a brand new one, and upload that summary and the latest code. This gives you a fresh, clean, focused context to start the next task. This quote from the original research paper really just says it all, doesn't it? We are redefining the line between just predicting the next word and orchestrating autonomous cognitive tasks. This model isn't just an assistant anymore. It's looking more like a foundational operating system for a whole new generation of agentic workflows. If you found this deep dive helpful, please be sure to like this video and subscribe to the Automation Architect channel for more advanced AI workflows and tutorials.